make sure to remind me. Okay, now it's recording. All right, so the topic of the day is introduction to proofs. And we'll get to what that means soon. But for now, let's talk about a couple other words. So a conjecture is a statement that is believed to be true. So it is believed to be true. So what that means is that you don't necessarily have a lot of proof to prove that it's true, but it's believed to be true. So for example, I could say something like, oh, it's going to rain tomorrow. That would be a conjecture because I'm not 100% sure. I don't have proof. It didn't rain yet, so I don't know for sure right now, but I believe it's going to rain tomorrow. So that's a conjecture. And then when you have a conjecture, you can use what's called inductive reasoning or deductive reasoning to prove that it's true. So if my conjecture is that it's going to rain tomorrow, what are some things I could use to prove that that's going to happen?
It rained yesterday.
Okay, if it rained yesterday, that could be something to prove that it might rain tomorrow.
The sky is cloudy.
Sky is cloudy. Good. What else?
There's thundering.
Okay, that's a big one. That's a really good one. It's thundering
Dark
outside.
clouds, like really, really dark clouds.
Really, really dark clouds. Exactly. So all of those things can be used for me to prove that it's going to rain before it even happens. The ultimate proof would be if it just started raining. I could be like, look outside. It's obviously raining. I was true. But until that happens, we don't know for sure. So you have to use different bits of information to prove that point. So there's two types of reasoning. There's inductive and there's deductive. So inductive is the process of reasoning that a rule or statement is true because specific cases are true. So what that means, so I could be like, I know it's going to rain tomorrow because last year on September 17th, it also rained. Is that necessarily true? Does that necessarily mean it is going to rain tomorrow?
No.
No, because every year things change, right? But that would be an example of inductive reasoning. If it happened before, if you can point to a specific time that it happened, that would be one way to try and prove that it's going to happen again. The reason I'm not highlighting this one is because that's not what we're going to be using. Instead, we're going to be using deductive reasoning. So this is the one that we're going to write down. So deductive reasoning is the process of using logic to draw conclusions. So go ahead and write that one down. And then using the rain example, we can think of some deductive reasoning that we could do. And I know I've got at least one person in the room who wants to be a lawyer someday. So deductive reasoning is exactly what you would be using in a courtroom as a lawyer. Because when you're a lawyer, you have to prove, let's say you have someone who did not commit murder, but it looks like they committed murder. You have to use a lot of different resources to try to prove that they actually did not commit that murder. So actually, let's use that example of committing murder. So let's say somebody was found dead and there was a knife left behind, and let's see, Alejandro has been convicted of the murder, but Alejandro did not actually commit the murder, and we know, and he has an alibi. He's saying that he was at the doctor's office at the time that the murder was committed. So what would be some deductive reasoning that we could use to draw the conclusion that he's innocent?
If he was at the
I think it's at the
doctor.
doctor's, right?
Yes. So Jalen said fingerprints.
We can go to the doctor's office and ask if they have any files proving that he was actually there, because you have to check in, obviously.
Exactly. So we can use files from the checking in process at the doctor's office. Anything else?
Do they have any cameras?
Cameras. Yes, good girl. All right, what else?
Maybe the relationship with the person that he killed.
Okay, you could find out more about the relationship, see if there was any reason that he could have murdered them for whatever reason.
Well, wait. Don't like some killers they leave behind some tracks.
Could have left behind some tracks. Exactly.
Instead of the knife, they could like left some blood, some hair,
DNA
Mhm.
some dandruff.
Exactly. Okay, so all of these things would be used in the court case to prove that, that he's innocent. Why can't I be 100% sure unless, like, I could be as close as possible, but what's going to prevent me from being 100% sure?
Because you weren't like right next to him when it happened or something.
Exactly. There were no cameras, nobody else was there, so we can't know for sure, but we can use all of these other things to prove our point. The other thing that's important with deductive reasoning is that you have to follow steps in order. So if you were following steps in order in a courtroom, what would you start off with? Oh, he didn't commit the murder because that's his best friend and he would never do that? Or would you start off with, he didn't commit the murder because here are the records showing from the doctor's office that he was at the doctor's office that day?
We start with that one because it has the most evidence.
Exactly. You want to start off with the one that has the most evidence, and then from there, if they have further questions, you could keep going and showing more and more evidence. So does that kind of... Say that again?
What if his best friend took his girl and he killed him?
Well, maybe exactly. That could be...
Yeah, okay.
That could actually be incriminating. So, okay. So that's basically what deductive reasoning is. Has anybody heard of Sherlock? You guys know who Sherlock is?
Yeah,
There's a TV show, there's books.
Sherlock Holmes.
Sherlock Gnomes.
Sherlock Holmes, exactly. Sherlock Holmes uses deductive reasoning to figure out the mystery that he's solving. Like, he will go into a room and he'll be like, okay, I see a fingerprint there, I see this over there, I see that she's wearing pink and she only wears pink when she goes. Like, he puts these things all together without actually knowing what happened. He can put it all together in order to draw a conclusion. So he's like the famous example. Okay. So what does this have to do with geometry? So in geometry, we've talked about postulates before. We talked about that yesterday. Or not yesterday, like the last class we did. Postulates are statements you accept are true without really needing any evidence. So for example, I could say, the sky is blue. Do we agree?
Yes.
Do we really need evidence?
Racist.
No.
No. Things like that are just statements that we know are true. A theorem, however, is a statement that you can prove is true using a series of logical steps. So a theorem is like, you got to show me the receipts. I don't believe you until you show me the receipts. That's what a theorem is. So go ahead and write that one down as well.
What is this, law school?
Legally Blonde. That's the movie. It's the best movie ever.
If you say so.
You should watch it if you haven't. I think it's on Netflix.
They have like a lot of legal plans.
So while you guys are writing, remember my example for a postulate is the sky is blue. Can anybody think of a statement that would be a theorem, something that you would need a little bit of evidence in order to prove? Even if it seems like obvious, you would still need evidence.
A statement?
Mm-hmm.
I did my homework.
There you go. I did my
I
homework.
like that one.
What else?
Does Miss Lopez need her glasses?
Miss Lopez needs her glasses? What kind of proof would you need for that?
If anyone says I need my glasses, I'll get so mad.
I'm nearsighted.
Your prescription.
You would need my prescription, yeah. You would probably want records from my ophthalmologist.
I have my glasses right here, but I don't need them.
So those are the two, that's the difference between a postulate and a theorem. A postulate is like a statement that's like obviously true. A theorem is a statement that you need a little bit more evidence to prove is true.
Okay.
All right, so that's our two big words for today. Let me just finish reading this paragraph. So the steps of deductive reasoning involve using appropriate undefined words, defined words, mathematical relationships, postulates, or other previously known theorems to prove that the theorem is true. So basically that's just saying when they ask you to prove that it's true, you have to use other things that are also true in order to prove that it's true. So for like, if you were trying to prove that you did your homework, you would have to have concrete evidence, right? Show me the homework, show me the website where you uploaded it. You know, those are very concrete things. But if I was trying to prove that Perla did her homework, I wouldn't say, oh, she told me she did her homework. Is that enough proof?
No.
No, you got to show me it.
No.
So that's basically what it's
Yeah.
saying, that you just need, when you are trying to prove a theorem is true, you have to use concrete evidence.
Okay.
All right, so let's jump to something a little different. So do you guys remember these from last year? The properties of equality?
Yes.
We definitely
I love
know, you guys definitely know the first four. You do not need to write this down, but I'm just showing. You guys know the first four. The other four, you might need to review a little bit because we didn't use them that much. But basically, the properties of equality are an example of concrete evidence. So these are already proven things that you can use to prove something else. So what does this mean? So before I explain how that goes, let's just make sure we understand all of them. So addition, subtraction, multiplication, and division, that's just when you do the same thing to both sides. The reflexive property is just saying that a number is equal to itself. So if I say 3 equals 3, that is a true statement.
Wow.
The symmetric property just shows you that you can switch things around when you have an equal sign. So if you have A equals B, it's the same thing as B equals A. That's all that means. The transitive property is kind of interesting. So that one tells me that if A equals B and B equals C, then you can kind of take away that B in the middle and just show that A is equal to C. So does anyone have a question about that one?
No.
Okay. And then the last one is the substitution property, which just means that you can substitute B. So if you know A equals B, you could substitute B instead of A anywhere you want. So that's kind of like when you get an answer and you get X equals 3, you can go back and plug that 3 into any of the other equations to figure something else out. Okay, so any questions on these properties before I show you why I even brought them up?
No. They
Okay,
seem
cool.
pretty simple.
Yeah, they're pretty simple. And I'm gonna leave them in the corner here to remind you. So we've actually done a proof in the past. You just didn't know it was a proof. So a proof, we will always write them down in this type of chart. So in your notebooks, I want you to write down the equation and then make a chart just like this one. You don't have to make it quite as fancy if you don't want to, but you can at least just do a T chart. So just do the T and then write statements on one side and reasons on the other.
But we just make that box.
Mm-hmm. The statements and reasons, and then write down the equation. So like I said, we've actually done proofs before. We just did them a slightly different way. So the way that proofs work, proofs are it's you trying to get to an answer and show each step of the way. So in this case, we want to use deductive reasoning. We want to prove. We want to use a proof to solve the equation. So our goal is to solve this equation. And we know how to solve. We've all done this before. We're just going to write it a different way. So the first thing in every proof, pretty much every single proof you will ever see, the first thing you always start off with is what you're given, the statement that they already give you in the problem. And in this case, you're given 14 equals 3x minus 4. Because that's just what they give you. They didn't give you anything else. And for that, for your reason, you will always write down given, because you don't need to explain anything yet. You're just showing that this is what the problem says, and now I got to go forward from here.
Okay.
And now from here, we're going to solve the equation, but each step of the way, we're going to give the explanation using our properties of equality. So using those properties of equality, what would you use next to get to the next step in solving?
Add.
Mm-hmm.
4.
And then the only thing that's changing here is that we're actually not going to show our work like we usually would. I'm just showing the next step. So in my head, I'm adding 4 on both sides. So I would just write down 18 equals 3x. And in the reasons, that's where I write addition property.
Oh, is this like where they give you the chart and they ask you to see where they went wrong?
Yeah, it's exactly like that. So little did you know they were preparing you for geometry even back in algebra.
Crazy.
Oh, Cosmo is good, but yeah, focus please. Maybe I'll show you him this week. The thing is, he gets really, you know what he loves? He loves 2 things in this world. He loves ice. So if he hears the clanking of the ice, he'll come running. And if he hears pens clicking, he loves that sound too. So he'll come running and he'll come up to my desk and he'll keep bothering me the entire time. So it's really hard to teach when he's in the room. So I always close my door, but maybe later this week, maybe. All right, anyways, my next step would be what?
Divide.
Get rid of the variables, so divide.
Good, we're gonna
Forgot half the
divide by
stuff we're
3.
doing here.
We divide by 3 on both sides, so that's the division property. And the goal, when you solve the equation, the goal is to get to x equals a number. And in this case, it's kind of backwards, right? Like the x is on the right side instead of the left side. So just as a final step,
Flip
we're
it.
going to switch them around. And which property was that from the previous slide? Who remembers?
Was it reflexive?
Not reflexive. That's the one where a number equals the same number. I can go back.
Yeah.
Wait, yes, can you go back, please? Okay, now, wait. Okay, you can go back to
Is
the...
it the one that says the one with the S, the symmetric property?
Symmetric.
Yeah,
Yeah,
symmetric
symmetric.
property. There we go. So even though this is an obvious step in your head, you still have to show exactly what you did to get to that point. So this is the symmetric property of equality. Okay, and we just solved our problem. All of those reasons that we used, that's the evidence. That is all of the evidence that you need. And notice it follows a very logical order. You can't skip steps. You can't put them out of order. You have to put them all in order from top to bottom. So any questions on this so far?
No.
Awesome. Let's do another. So I want you guys to do this one on your own. Do the same thing, only write down the problem and your chart. And then we'll go over it together. So I'll give you guys like 4 minutes to do that on your own. Jalen, yeah, you can get water. Let me see how many minutes y'all got. Okay, you still have about 2 minutes left, but if you guys finish early, you can just send your answer in the chat so I know you're done.
Ms. Lopez, would combining like terms
Mhm.
go be like a different step?
Good question. I don't see a place in this case where you're going to need to combine like terms. So which step, when we go through it, let's see what we did differently, and then we'll discuss it.
Oh, never mind.
Okay. All right. Couple seconds left, so finish up what you've got. Okay. So what do I start off with always?
The equation they gave you.
The equation they gave you, whatever they gave you, and you write given. Okay. And then I'm going to go through it and justify each step. So what's the next property?
Subtraction.
Good. Okay. I'm going to shorthand of equality just because I ran out of space. Okay, so I have to do it in my head. I'm not going to show it, but I'm going to do it in my head. When you subtract 17 from 9, what do you get?
8. -8.
Good. All right, what's my next property?
Division.
Division.
Thanks so much. You're in class today.
You're so weird.
In my head, I do it, but I just write down what I get. And then what's that last step? It's very similar to the previous one.
Your pencil battery is low. I saw it.
Yeah, I know. What's my last step?
Symmetric property.
Good. All right. So do I have any questions on how to do these proofs at this point? Charge up my Apple Pencil.
No, this is simple.
Cool. All right. Well, now we're going to do the same thing. Nothing's changing. We're still doing proofs, but it's going to be with geometry. So that's why these were all algebra. Now we're going to move on to doing them with geometry.
Awesome.
Do that just like we had those rules of properties of equality. Those are the properties we use for algebra. In geometry, now we have to think back to those postulates because those are going to be our proof. That's going to be our receipts. So I just wanted to bring these back. We've done these in the last couple of classes, but just to review, you have the segment addition postulate, which just basically tells you that if you add two portions of a segment, it equals the whole thing. So A to B plus B to C equals A to C. And then similarly, you have the angle addition postulate, which is basically the same thing, but with angles. It just tells you that if you've got one big angle split in two, when you add those two parts of it, you get the whole thing. So do I have any questions to clarify the postulates right now?
Nope.
Cool. All right. So we're going to do a proof. Same thing, just geometry. So what did I say you always start off with?
The given equation.
Given equation, and it's right here. So I want you guys, matter of fact, before we even start with it, write down the given equation, make a little diagram for yourself that looks like this, and make your chart. Go ahead. Your diagram doesn't have to be perfect, just as long as you have it in front of you so that when you go back to study, you know what you did in class. Couple more seconds to finish writing and copying. Tyrone, you writing? I don't see you writing. All right, when you're done, give me a little thumbs up so I know you're done. I love Janelle's arm coming in from the side like that. All right, most of you guys are good. All right, cool. So just like we said, we're gonna start with our given statement. Also, let's just make sure we know what we're looking for in this case. So in this case, we want to find the value of x. That's all we're trying to find. So we know that our final answer should be something like x equals. But starting off, I'm going to start with what I know. I know that RT equals 5x plus 12, and I know that because it's given. Then I need to figure out how I'm going to find the value of x. So could anyone think of, back to the postulates that we just went over, which postulate can I use to give myself the next step in the process?
Postulate 1.
The segment addition postulate. So what I'm going to do is I'm going to state the postulate in the statements. So in this case, I don't have the same letters as the previous, like here I had A, B, and C. Here I have R, S, and T, but it's still the same thing. So I know that RS plus ST equals RT. And the reason is because that is the segment addition postulate. Now that I have that information down, what can I use from my diagram for my next step?
Like the numbers? I mean, like the equation, expression, I don't know, I forgot.
Yeah, the expressions, yeah. So I know I have x plus 2, I have 3x minus 8, and I have 5x minus 12. So I'm basically going to take those and I'm going to put them in to this equation that I've set up. So I have x plus 2 plus 3x minus 8 equals 5x plus 12. Questions on that?
Mm,
Good. All right. The reasons for this one, we can put, what did we technically just do? You can think back to these properties over here.
We substituted them.
Yeah, we did. We substituted. That's all we did. We plugged everything in. So this would be our substitution property. And from here on out, I actually didn't put the right amount of lines into my graph, into my diagram. So I can't change that about it because it's already like a PDF, so I can't change it right now. But what you would do is you would go through and solve it just like you did in these questions over here. So I'm not going to ask you to do that right now because I do want to keep moving, but we can do the next step at least. So in the next step, what would you do to solve this problem, to solve this equation?
Would you combine like terms?
Mm-hmm. So I would combine like terms. That would be 4x minus 6 equals 5x plus 12. And you can actually just write combine like terms. That's totally fine. And then you would go through, keep using those properties, keep solving to get your final answer. So matter of fact, I'm not going to write all of the steps down now because you guys know how to do it. But as practice, why don't you guys go ahead and solve it on your own and just give me your final answers. Take 2 minutes.
okay.
So again, you don't have to write all of them down in this chart, but let's just practice solving and get your final answer. And drop your answer in the chat when you get it. All right, so coming back, because I don't want to spend too much time on this, I noticed I wrote down, if you were writing it from the chart, you did it correctly, but I wrote down a plus instead of a minus here. It's only going to change your answer slightly, but that should be a minus. Okay, I saw a couple answers in the chat. I'm just going to go through it. You should have gotten, if you wrote it down correctly, you should have gotten x equals 18. All right, any last questions on solving that equation?
Ms. Lopez, are there gonna be like charts like these on tests? Like
Yeah, and I'm going to show you what it looks like on a test.
okay.
Yeah, we'll get to that. Okay. In fact, we only have like one more. No, we'll do, yeah. So you'll see a test question.
Wait, what time is it?
1:40, 1:19. My iPad has the wrong time for some reason. It is not 9:41. I'll give you that. Okay, let's do another one. So we, in this problem, my bad, this was A, the previous one was A, and this one is B, but they're asking the same question, which is solve for X. So you're trying to solve for X. Use a postulate or theorem to find the value of X. So what am I always writing down first?
The given form equation.
Given equation. So that's going to be the measure of angle RST equals, and they put it in parentheses, so I'm going to keep it like that, 15x minus 10 degrees. The reason they put it into parentheses like that is to put the degree symbol applies to all of that. And this is given. And we're trying to solve for X, so same idea, we're trying to get X equals, right? So using the postulates we've learned, who remembers the name of the other one?
Postulate 2.
Yeah, but it has a name. You gotta know these names, guys.
Addition. No. Let me
Can you
search.
go back?
No, I'm not gonna go back. I wanna see who remembers it.
I'm gonna search
I
it.
do not.
Postulate. It's postulate 2, right?
Mm-hmm.
Okay.
She said I'm gonna search it up. I thought she meant online. I hear her flipping through the notebook.
No, I'm gonna search it up in my journal.
Why my eyes look yellow? Wait, that's the background.
Tyrone, you should be looking in your notes right now. What's postulate 2 called? Okay, I'm just gonna give it to you. This is taking too long, you guys. You gotta
Thank you.
memorize these. Angle addition postulate. It's what they mostly always are called what you're doing. Here we're adding,
Can you go back so I can screenshot it?
yeah, there you go.
Wait,
All right.
Quick, take a picture, quick.
okay, go.
Okay.
Miss, I was like, do I not have it? Because I thought it was like in the other word where it was like point. And
Oh,
and
sorry.
Oh, it was like here.
Okay, so the angle addition postulate tells me that I can add these angles up. So I know that the measure of angle RSP plus the measure of angle PST equals the measure of angle RST. So I'm just reiterating the angle addition postulate. And now it becomes pretty similar to the previous problem because what can I do from here in the next step?
You can.
What should I do here? I have an equation. I have a diagram with some information. Perla said it in the chat. Yeah, we're going to substitute. So I'm going to substitute all of these values that they give me already in the diagram. So I know that RSP, that's x plus 25. Oops. PST is 5x plus 10. And all of that is going to be equal to 15x minus 10, because that's the big angle. That was our substitution.
Okay.
Very similar to the previous one, we can combine like terms. So this is 6x plus 35 equals 15x minus 10. And we would go through, do each step one at a time and solve the problem. Except right now we're not going to do all that because from here I trust you guys already know how to do this. So we're going to skip that part because I got to move on. But do I have any questions on the two postulates that we went over, or again, any questions on how to put together a proof?
No.
Awesome. All right. We have one more definition for today. So this we will be writing down, and I'll show you exactly which parts to write down. So we're going to write down the linear pair theorem, the actual words it says, and then the word supplementary, in case you don't know that, that means that they add up to 180 degrees. So if you don't know that, then make sure you write that down as well. Write down the name of the theorem, the definition, and that little definition at the end. And give me a thumbs up when you're done writing.
Do you want us to write the angle too?
Nope, just the parts I highlighted.
You're correct.
Okay, Perla's done. Janelle's is done.
Wait, I'm almost done.
Okay, Tyrone's almost done. Couple more seconds. Let's not talk about it, Perla. No, I'm kidding. I have algebra students too. I have 8th graders in algebra. So it's not the same. All right, moving right along. Here's an example of one that this is what it would look like on a test. So on a test, you don't necessarily have to do each and every step. You're going to have to fill in the blanks. And this one, you only have to fill in 4 blanks. But as it gets harder and harder, you'll probably have to fill in more blanks. And in this case, I gave you a word bank, but sometimes you're going to have to do it without a word bank. So this is very introductory right now. I'm just getting you guys used to it. But you'll see that they get a little bit harder and harder. So let's look at what this is saying. Prove the linear pair theorem. So this basically wants you to prove what we just wrote down. We just wrote down this proof, this theorem, but now we're being asked to actually prove that it's correct. So they give us this statement, given MJK and MJL are a linear pair of angles. So that's showing me that these two angles are called a linear pair. That means that they are on the same line. So what do I write for number 1? Look at the word bank and remember, what do I always write for
Given.
them? Yeah. We always write given for our first step. That's the easy one. Now we have to kind of look and see what they said in the next statement and try to figure out how they got there. So using the word bank, try and figure out which of those would fit best for number 2. So statement number 2 is saying that JL and JK are opposite rays. So let's look at JL and JK. So it's telling me that the one on the left and the one on the right are opposite from each other. What do you guys think? It might not be something you've seen before, but which of the remaining answer choices seems to make the most sense?
Two?
The definition of a linear pair?
Oh yeah, I think so.
Yeah,
Mm-hmm.
that's basically it. You've never seen it before, but it kind of makes sense that it's telling you those two rays are opposite, so if they form a straight line. So there you go. Definition
Yay.
of linear pair. And you'll see that a lot because in the first part, they made a statement about a linear pair. So the next step is to tell me what is a linear pair. That's a good that's going in chronological order. And then notice they do the same thing. They tell you that these are opposite rays, and then they tell you that's the definition of opposite rays. You see how that pattern keeps going? All right, next they tell us that JL and JK form a straight line. Okay. After that, they tell us that the measure of LJK, so where's LJK? LJK is the whole thing. This whole thing, they're telling us that that is 180 degrees. Why is that? Because that's the definition of a straight angle. For number 5, they're telling us that MJK and MJL add up to make LJK. So look at your options, your answer choices, and what do you think fits here?
Angle addition postulate.
Perfect.
Is
That's
it
our
postulate or postulate?
postulate.
Postulate. Oh, it's so weird.
That's our angle addition postulate. Those two smaller angles add up to the bigger angle. Okay. Once I know that, I also know that the two smaller angles have to add up to 180. Obviously, the only thing left is our substitution property. Can anyone point to how they did substitution here? What did they substitute? Where did they take it from?
They took the straight angle LJK.
Mm-hmm.
Since they knew it was 180, that's why they put 180.
Exactly. Right here, you have, it's telling you it equals 180. So they took out this LJK and they replaced it with 180. That's your substitution. Okay. Kind of different from things we've done in the past in our lives, but is it kind of making sense now how these proofs work? Give me a little thumbs up if you're following. Even if it's a little confusing, you're still following along. Okay. Couple thumbs to the sides out there. I have a good thumbs up from Samaj. Anyone else have a thumbs up? Emily's got a thumbs up. All right, cool. Let's do another one. This one's another, so the next two problems are both challenge problems. So these are going to be like even harder, but we're going to follow the same ideas. So all we need to do is fill in the blanks. So the process is you have to look at what they did and try and figure out why they did it. So for this one, I know there's a lot to write down. So for this one, I think the best thing to do is just follow along, actually. Don't write it down. Unless you want to. You can take a picture of the screen and finish writing it down later, but I don't want you to take too much time writing right now. All right, so we're given 1 and 3 are vertical angles. So let me quickly define what that means for you because we haven't gone over that yet. So a vertical angle is when they're opposite each other. So notice how 1 is across from 3. That's all that means. Vertical angles are just across from each other. So that's what we're given. So what do I write down for number 1 for my reasons?
Given.
Given. Easy.
They told you the answer right there in the sentence.
Yeah. You guys should never get that one wrong when it comes up on a test. Oops. That's our given. Oh, and my pen decided to stop writing. Awesome.
It's dead.
Oh, I think it died finally. I was like plugging it in every time we stopped. Oh, it's back to life. Okay. Given. All right. Then they're telling us that 1 and 2 are linear pair, and then 2 and 3 are a linear pair. That just comes from the definition of a linear pair, which just means that they're next to each other. Not across, but next. So 1 and 2 are right next to each other. And then when you look the other way, 2 and 3 are right next to each other. That's a linear pair. Any questions on that? Cool. All right, then they go to say that 1 and 2 are supplementary and 2 and 3 are supplementary. What does supplementary mean again?
They,
That they add up. Oh, you lost so much.
no, it's fine. Say it.
I forgot what it means.
Is it when they add up to 180?
Yeah, they add up to 180. And how do we know that? Look at the word bank. And which of those tells us that these are supplementary angles?
Linear pair
Yeah,
theorem. Yeah.
exactly. The linear pair theorem, which we just looked at back here, is exactly where you get that information. That's your proof. That's your receipts. All right, what do they do next? They kind of take the same statement, but they show it using math. They're showing you that angle 1 and angle 2 add up to 180, angle 2 and angle 3 add up to 180. What do you think? So that could be substitution, but I actually think it's another one. Can someone else? Because the thing is, you could say it's substitution, but do we know yet what the definition of supplementary is? Did I say it out loud yet?
No.
I haven't even told you. So in order to show that this is substitution, before you even do that, you have to tell me that the word supplementary means 180 degrees. So that's what they did in the next step. They're showing us the definition of supplementary angles. And I don't have a lot of room, so I'm shortening everything. That one was a little tricky. So do I have any questions on how I went from step 3 to step 4? Okay. Now, could we say the next step is substitution, or would you go for the angle addition postulate? I see no ma'am. What do you guys think is the next step here?
Maybe the angle addition.
Maybe the angle addition postulate. So let's go back to what is our angle addition postulate again? It tells us that two angles located next to each other add up to the whole bigger angle. Is that what this one is saying?
Wait, can you say it one more time?
Sure, I'll even go back to it. Hold on. There, angle addition postulate. That one's the one where two angles next to each other add up to the bigger angle they create. So is that what we're working with here? Using words, how do they go from step 4 to step 5? Like, what do they literally do to go from this one to the next one? Does anybody see it?
All I can think of is AB equals BC. I don't know why I'm thinking of that.
Well, okay, so they have this part of it matches to here,
Yes, yes, it does.
right? And then this,
Oh, it is. I think it is. I agree with Janelli then. Wait, Janelli said that, right?
that what?
Angle addition postulate.
But is that what I'm doing though? Like I'm taking the red
I don't
part
think so.
and I'm making it equal to the blue part. How do I know they're equal to each other?
Because of, I'm gonna take a guess, and I'm just gonna say it's substitution. I don't know.
Yeah, you got it. Because we know that the red equals 180. We know that the blue equals 180. So they're both 180, which means they're equal to each other. Does that make sense?
Yes.
So all I did was I took the blue and I substituted that in for 180. So this is substitution for sure. That's substitution. Okay, so we actually did not use the angle addition postulate at all. That was a trick. Sometimes they'll do that. They'll give you more words than you need. But how do I get to that last step using algebra? Using algebra.
We are going to get rid of the M.
Mm-hmm.
I mean the measure of angle 2.
Right. They got rid of measure of angle 2, and what property did they use to do that?
That's where I'm confused. Like we have 2 of those.
What could I do to both sides that would cancel it out?
Subtract.
Yeah, that's it. Subtraction property.
Okay.
So it's not easy. I will give you that. It's definitely not easy, but the more you guys see the patterns, the more it's going to make sense and the easier it's going to be on a test. So I want to give you guys one last one before I have you guys go. So any questions, final questions on this one?
Nope.
All right. Let me just make sure. Yeah. Okay. All right. So now instead of filling in all the reasons, we're going to fill in all the statements. And this one is definitely a challenge because there's a lot going on, but we're going to go through it together. So who would like to read the situation up at the top?
Emoj.
Go ahead.
Michaela is using the following information to prove that. How do you pronounce that again?
So angle TUS.
Angle TUS and angle PUQ are complementary angles in the diagram shown. Part of her proof is shown below. Given the ray US bisects angle TUR and the ray UQ bisects angle PUR.
Perfect. All right. So the reason I highlighted what I highlighted is because in the question, they're actually telling you what you want as your final answer. You want to prove that angle TUS and angle PUQ are complementary angles. So where in my word bank can I already cross something off?
The 2 last ones.
Okay, so I know this one right here. This is the same, it's matching exactly. Angle TUS and angle PUQ are complementary. And where is that going to go?
The
At
last.
the last one.
That's my last step, exactly. You always want to show whatever you're trying to prove, that goes in the last box.
Mm-hmm.
Complementary. Now, let me define that for you guys, because we said supplementary adds up to 180. Complementary adds up to, anyone want to guess?
90.
360.
Yeah, she had it, 90. So supplementary is 180, complementary is 90. So we're trying to prove that TUS, and let me highlight them. We're trying to prove that TUS right here and PUQ right here add up to 90 degrees. Okay. What's the other easy one that I can fill in right from the start?
The first one.
Mm-hmm.
Yeah.
And where do I
Because
look?
you put out the first one because it's the given one.
Good. That one's always given. So I never want to see that one wrong on a quiz. I will get mad at you if it is. So where do you see that one? I think Perla said it before, but where do you see it? Look in the word bank. Where is it?
The last one, isn't it?
Yeah, the last one. Here it is. All right, so I'm gonna write that down. So I have US, and I'm gonna write it with my symbols right here. So that's ray US bisects angle TUR, and ray UQ bisects angle PUR. That's given. Okay. Now let's look at the reason for the next step. So the next one should be the definition of angle bisector. So look at the word bank and try and figure out which of these is giving you the angle bisector definition.
I think the second one.
The second one. So the second one is saying TUS plus SUR. So let me show you that. So it's saying TUS and SUR equals TUR. So it's telling us that the two smaller angles equal the larger angle. And then the same thing for the other side. It's saying that the two smaller angles on the right side equal the larger angle. Is that the definition of an angle bisector?
Can you repeat the question, Miss?
I'll say it one more time. Remember, the angle bisector means that it's cutting it in half, right? So does this statement, number 3, tell us anything about it being in half?
No.
No. So that's not going to be the one. But now look carefully. Which statement tells you that this guy is cutting it in half and that this guy is cutting it in half?
Is it the angle?
I think it's the fourth one.
All right, let's look at the fourth one. 1, 2, 3, 4. This one? TUS and PUQ equal 90 degrees. Do I know anything about how much they measure yet?
No, never mind.
No, so I can't get there yet. Keep looking.
Definition of angle bisector.
RUQ.
Is it?
Well, it's not the second one.
It is not the second one because, again, we don't have any measurements yet.
Is
It's not the third one either.
it the fifth one? Or
Do I have any measurements?
wait, no.
Mm-mm.
Wait, so the only option is the third one.
There's one you guys haven't mentioned yet.
I'm confused. What?
Wait, we said all of them. 1, 2. Oh wait, yeah, there's 5. We said all 5. Wait.
It's the
There's
third
one. Okay, Emily just said it. The first one. You guys didn't say that one yet. Yeah. So what's the first one saying? The first one is saying that TUS is
Nick,
equal
I was
to.
putting the number 1 up.
Oh, I didn't see your hand. Okay. I wasn't looking at the screen. I'm sorry.
Mhm.
All right. Yeah, that one's showing us that TUS is equal to SUR. So I'm putting these little arcs to show that they're equal. Same thing with the other side, RUQ, and I'm going to put 2 arcs and 2 arcs. So those little arc symbols show me that they're equal. When there's 2 of them, you look at the one that also has 2. That's all it is. Yeah, that's showing us that it's a bisector. So angle TUS equals angle SUR, angle RUQ equals angle PUQ. All right, so I'm gonna cross that one off. All right, next one. Now, here's where you guys already mentioned this one. Which one of these is telling us or is defining the angle addition postulate?
The angle addition postulate.
Remember, you're looking for something where 2 smaller angles equal the bigger angle.
The third one.
There it is. Yeah. The third one. The third one is talking about the 2 smaller angles equaling the bigger angle. So this one is TUS plus SUR. So the 2 smaller ones equal the big one on the red angles. And then in the yellow or orange angles, it's the same thing. RUQ and PUQ equal PUR. Okay. We got that out the way. Now we can start talking numbers. What is the linear pair theorem again? What does that one tell you about a linear pair?
They equal 180 all the angles or something?
Yeah, they equal 180. So which of these can you use to show the linear pair theorem?
Mm-hmm. The fourth one? No, the fifth one.
The fifth one, good. So that's TUP plus RUP equals 180. All right, next, I'm using substitution. So where do you see something that could be substituted?
The second one.
Yeah, the second one, because that one also has a 180. What did they substitute in? So instead of TUP and RUP, what did they use here? So notice I have now, instead of TUP plus RUP, I'm writing 2 times TUS and 2 times PUQ. Where did they get that from?
Can you say it one more time?
Yeah, and I'm going to highlight them too so you can see clearly. So I used to have TUP,
Mm-hmm.
which is this one. Wait, TU. I think that should have said TUS. I'm sorry. Yeah, that should have said, or no, that should have said TUR. That's my bad. Anyways, I had this one
Okay.
and this one. So it was saying that these 2 angles are a linear pair. Those add up to 180, right? That was step 1, 2, 3, 4. In step 5, now I'm saying that 2 times TUS, which is this one, plus 2 times PUQ, which is that one, equal 180. So my question is, why can I do that? How could I know that? How did they jump from step 4 to step 5? Even without using all of these theorems and things like that, just use your eyes and your what you know. How do I know that 2 times the red angle and 2 times the orange angle give me 180?
Hold on.
Wait, so 2 times the red angle
Mm-hmm.
plus 2 times the orange angle will give you 180?
Mm-hmm. How do I know that?
I'm confused.
It seems like a bunch of gibberish to me.
What is a bisector again?
Split something in two.
Split something in two, and not just in two, but in half.
Oh yeah.
Right? So what do I know
Okay.
about, here, I'll color code everything. What do I know about the red and the purple?
That they were bisected.
They were bisected. S is the bisector. So that middle where they mash together, where it's purple and red, that's the bisector. So what do I know about the red and the purple?
And the purple, the red, and the purple were. Wait, give me a second. I'm lost.
What do we know about the purple?
Purple and red.
That they're the same.
They're the same. They're equal.
And so
I already went, in step 2, I already covered all that. What do I know about the orange and the green?
But they were
also
bisected by Q.
They were bisected by Q, which makes them also equal. I already also went over that in step 2. So they're equal, right?
Yes.
Okay. So in step 5 now, which is what we're on down here, now I'm saying that 2 times the red and 2 times the orange give you 180. So why can I do that?
Because they've both been bisected into equal parts.
Because they've both been bisected into equal parts. So in other words, the purple can also be red because they're equal to each other, right? Red equals purple.
Purple equals red.
So instead of making one red and one purple, they can both be red now. Same with the orange. Orange equals green. So instead of having one orange and one green, I can make them both orange. So what I'm saying in step 5 is that 2 orange angles plus the 2 red angles are going to give me 180.
Bless you.
Does that make sense now?
Yes.
Okay, good. Cool. So now I only have one step left because I already wrote this one down. My final step is the only one left, but how do I know that that's true? Just to make sure I'm doing things correctly?
You
What did they do?
They took the 2 angles and added them.
You can't really add them like that. Look at all the numbers. Look at the pattern all the way across. To get from step 5 to step 6, what happened to that number?
they have to be divided by 2.
Yeah, they divided everything by 2, which took away all of those coefficients, and then the 180 got divided by 2 to make 90.
Okay.
You see that pattern now?
Yeah.
Yeah.
Okay. And that is the completion of our very long, pretty challenging proof.
Yeah.
So that's kind of like the tricky part with these things, is that you really, really, really need to see the patterns. So all of those color coding, all of that, which I did, you have to be able to do on your own as well. If you can't see it, it's very hard to understand it. So going forward, whenever you do have a proof question on a quiz or something like that, my suggestion is draw it out in front of you. If you have colored pens, like I know Janelle's does, but if you happen to have colored pens too, that's very helpful as well. And then also, just like I did, process of elimination, as you go through, cross out your options and then see which one of them makes the most sense in any missing step you have. Any final questions? Because that is it for today.
No.
Okay, I have a couple announcements. Number one is I will be posting homework in like 5 minutes after we log off. I'll be posting homework, and that's going to be due on Friday at midnight. And that homework will be, you'll have one assignment that's very similar to today's class, and then one assignment that's going to be more like tomorrow's class. So when you log on, if you're trying to do it tonight, there's going to be one that makes sense and one that we haven't learned yet, which you can still try if you want to, but it's going to be different from what we've done. Samaj, you have to join this class, right? You don't have an
Yes.
account. And Daniel, you too. Daniel, make sure you make a new account. So I'm going to send you a link right now with this link. I'm putting it in the chat, and just click on it, and then you'll be able to create a new account, use a new username and a new password that you're going to remember, and write it down, because I'm not going to write it down for you.
Okay.
Okay, so just click that link, and then it'll send you to make a new account, and you can do that. And then my final announcement is that we are still iReady testing. Like I said, we don't really have time anymore during class because I do need to teach. So instead of doing it during class, you guys have to find time in between classes, before classes, because it opens at 8 a.m. And on Friday, I'm not going to be here. So if all else fails, if you haven't found time to do it during the week, you will have time during class on Friday because I'm not going to be here. But I expect everybody to do it on Friday if you haven't finished it by then.
Okay.
All right, so any last questions?
No.
Nope.
All right,
Nah.
so Daniel and Samaj, make sure you sign up. I will be posting the homework assignment in 5 minutes, and I'll see you guys tomorrow.
All right. Bye.
Alright.
Okay, bye everyone.
Bye, miss.
Bye.
Bye.